Unit 4 Test Study Guide, question number 1. Alright, determine if the quantities in each pair of ratios are proportional. Remember, if they're proportional, they're equivalent ratios or equal ratios. So one way to do this, find the unit rate. $3, and that's the way we've been doing it all year because that's the 7th grade standard. You want to know how much is it for one soda. How many dollars it is for one soda. So to do that, you're going to need to divide that denominator by 4. Whatever you did to the bottom, do the same to the top. And so to do that, you're going to have to do long division. The denominator you don't have to do anything with. 4 divided by 4 gives us 1. 3 divided by 4. The 3 is what's being divided. It goes inside the division sign. 4 goes on the outside. Put a decimal point, tack on a couple of zeros. The decimal point goes straight up because you're dividing by a whole number. Forget about the decimal point and just divide. 4 does not go into 3. 4 would go into 30 7 times. That would give you 28. Subtract, you get a 2. Bring down your 0. 4 would go into 20 5 times. This is 75 cents for one soda. You need to find out if the other one is the same. That's $8 for 10 sodas. And you want to know how much is that for one soda. So you want to make that denominator become 1. You're going to divide it by 10. Do the same thing to the top. Divide the top by 10. Again, the denominator, 10 divided by 10, that gives us our one soda. You need to do 8 divided by 10. Put the 8 on the inside the division sign. Put a decimal point, tack on a couple of zeros. Again, because you're dividing by a whole number, decimal point is right where it needs to be. Just move it up into the answer. 10 does not go into 8. 10 would go into 80. 8 times exactly. You would be done. If you brought down that other 0, it would go 0 times, and it makes sense to fill in with two decimal places because we're talking about money. This is 80 cents for one soda, so that is not proportional. Don't forget there's the other way to do this using that 6th grade shortcut, which is just to say $3 for 4 sodas. You can divide by 4 and you can go to a fraction. Or the way I like to say it is, you just put a 1 under this for one soda, and then push this number up, and you've got 3/4 of a dollar for one soda. That's our unit rate. The other one, $8 for 10 sodas, do that same thing. Make it one soda, and in ways this is the same work, but you are dividing by 10 and you're going to a fraction. That becomes 8 over 10. So it's 8/10 of a dollar, which in ways makes sense as a decimal. Or if you reduce it, that by dividing both of these by 2, you get 4/5 of a dollar for one soda. So your unit rates, 3/4 and 4/5, those are not equal, just as back here, 75 cents for one soda and 80 cents for one soda are not equal. This is not proportional. Okay, question 2. Mr. Jordan grades 3/8 of a test in 3/4 hour, Mr. Yost grade half of the quizzes in 3/5 an hour. Are these ratios proportional? Are these rates proportional? We're going to have to deal with fractions. So this is Mr. Jordan does 3/8 of a test in 3/4 of an hour. Remember, you want to put the dependent over the independent and you normally, almost always, put time as your independent variable. So this is going to be 3/4 of an hour on the bottom, and in that time Mr. Jordan does 3/8 of the quizzes. You want to find out what the unit rate is. You want to know how much he does in 1 hour. So to do that, you need to make that denominator become 1. To do that, you're going to divide by 3/4. You're going to do the same thing to the top. Divide it by 3/4. Go off to the side to do your work. Take your time, write down what it is. It's 3/8 divided by 3/4. Again, you don't have to do the denominator. 3/4 divided by 3/4 is 1. That is pretty obvious. Here, 3/8 divided by 3/4, we don't really divide with fractions. We multiply by the reciprocal, or you do keep, change, flip, or keep, dot, flip. So that becomes multiplying, and then the reciprocal of 3/4 is 4/3. Reducing before you multiply is a wonderful trick. So the 3 reduces with the 3. They're both divisible by 3. They become 1s. 4 and 8 are both divisible by 4. So the 4 becomes a 1. The 8 becomes a 2. You get 1/2. So he gets half of the quizzes done in 1 hour. And now we need to figure out Mr. Yost's rate. And his rate, again, quizzes over time. He does 1/2 of the quizzes in 3/5 of an hour. And again, you want this to become a unit rate. I'm going to hope that some of you guys would have noticed right there that you can already tell they're not going to be equal because Mr. Jordan had the same amount of quizzes. But let's go ahead and do the work. You want to know how much is it in 1 hour. So to do that, you're going to divide by 3/5 to make this become 1 in the denominator. Do the same to the top. Divide by 3/5. Again, come off to the side to do the work. 1/2 divided by 3/5. Again, copy dot flip. 1/2 times the reciprocal, 5/3. You don't really divide fractions, you multiply by the reciprocal. And this time, nothing to reduce. I'm just looking to see that I've got all my work right. Nothing to reduce. You get 5/6. He gets 5/6 of the quizzes done in 1 hour. So this is not proportional. 1/2 to 1 is not the same thing as 3/5 to 1. So this is not proportional. Question 3. Is this a proportional relationship? Remember, with this, you need 2 important things. You need a straight line, which we have. But to be a proportional relationship, that straight line has to go through the origin. This is not going through the origin, so this graph is not a proportional relationship. This graph, again, straight line, it is going through the origin. This is a proportional relationship. I'd also like to point out to you one other thing. It has to go through 0, 0. When there's 0 of the x, there's going to be 0 of the y in a proportional relationship. The other thing I'd remind you about is this ordered pair right here. When x is 1, r is the unit rate. So you can actually get the unit rate off the graph. If we could read this well enough, we could follow that along and know the unit rate just by